Hi everyone, and welcome to my Beginner's Guide to Go course. Now, in this course, we are going to be covering pretty much everything you need in order to get up and running with the Go programming language. I'm going to be assuming no prior Go knowledge and experience, and cover everything in depth so that you can walk away from this course a competent and confident Go developer. My goal for this course is to give you a learning resource that I personally would have liked when I was first starting out with the language. I want to go beyond the basic syntax and provide you with that little bit extra so that you can get up to speed and impress your colleagues. Now, throughout this course, we are going to be covering a lot. We'll be starting off with the setting up of our development environment, and then we'll move on to writing small applications that will cover individual blocks of the language, such as the control flow, functions, methods, and so on. And we'll be growing in complexity as we move throughout this course. Now, by the end of this course, you should have the knowledge necessary to start tackling some more advanced challenges and projects. And I'm going to be sprinkling in a few quizzes and challenges here and there to help solidify your knowledge and provide additional reading resources if you want to dig a little deeper. For premium Tutorial Edge clan members, we also have the Discord server where you can jump on and ask any questions around the Go programming language, and I'll be happy enough to provide you with additional support should you need it. Cool. So, with all that said, I hope you enjoy the course. Now, before we can set off on our quest to learn Go, we're going to need to install the Go command line tool on our local machine so that we can effectively transform the Go code that we're going to be writing into the binary executables which represent our final applications. Now, these days, the best way to install Go on your local machine is to navigate to the official Go site, golang.org/doc/install, and you should be able to use the installer for your particular operating system and architecture here, and it will handle everything like setting up the path environment variables needed in order for you to run Go on your command line. Now, once you have run through the installer, you should then be able to navigate into the terminal and run Go version and validate that your Go installation has been successful. So let's do that now. Go version. And as you can see, I'm running Go version 1.16.3 on the Darwin AMD OS and architecture combination. Now that we have Go successfully installed on our machine, let's try and write our first Go application. Now, I have created a new directory under which this application is going to live. I'm going to create a new file called main.go. So the first thing I'm going to do here is to define a package main and a func main. I'm then going to do print line, hello world, like so. So let's dive into what this means. Well, the package main and the func main are a special combination that effectively act as the entry point or the starting point for any Go application. Now, if we wanted to run this application, we could do so using the go run command and passing in the name of the file, so go run main.go. And as you can see, it's printed out hello world. Now, in this instance, we are running this through the Go command line tool. If we wanted to execute this as a binary executable, we could build it using the tool. So go build. The output for this is going to be called main, and we want to pass in the main.go file. So that's going to go away, take all of this source code here and compile it as a binary executable. And if we print out the contents of this directory, you can see the README, you can see the executable here, and the main.go file, which we built this executable from. So let's try run our application, /main, and as you can see, our application has printed out hello world. So whilst this application isn't the most complex, this does represent the first and arguably the most important step in your journey towards learning Go. You have created your first application, you've successfully compiled it to a binary executable, and you've been able to execute that executable. Now, in the next videos in this course, we're going to start to add complexity to our application, and start to introduce some of the basic syntax that you'll need in order to write more advanced Go applications. Now, in this video, we are going to be covering the topic of variables within Go. Now, variables are effectively in-memory storage locations for bits of information that could change throughout the course of our application's execution. Now, in Go, there are a number of ways to assign or create new variables, one of which is to just simply create the name of the variable and then use this colon equals syntax here to then instantiate and assign the value of that variable. So in this case, we'll call it hello world. And then if we wanted to use this variable, we could then just replace the hello world string here with the name of the variable that we want to print out. Now with these changes made, let's try and run this locally. So go run main.go. And as you can see, it's been able to successfully print out the value of the variable welcome that we have just defined. Now, in this case, we have allowed the Go compiler to infer the type of the variable welcome. If we wanted to be more explicit, we could use the var variable declaration and then the name of the variable we want to define and the type of the variable. So in this case, we want to define the welcome variable and it's going to be of type string. And if we wanted to, we could assign this to a value hello world, like so, and remove the original. We'll comment it out for now. Now, one noticeable difference here is that we are not using colon equals, and that is because we're not using the short variable declaration syntax here. We've used a more verbose variable declaration up here, and then we've assigned it to the value hello world. Now let's try and execute this in the terminal. So go run main.go. And as you can see, there has been no meaningful impact to the way that our application runs. The only difference is that we've been more verbose when it comes to declaring our variable, and we've explicitly set the type to string. Cool, so we've used two different ways of instantiating a variable here that have been of the type string. Let's take a look at another example and try and create an integer object. So let's say my age. We'll use the short variable declaration, which uses the colon equals syntax, and then we'll assign this to 27. And then we can then use the println built-in function to then print this out. So my age, like so. Let's go into the terminal, go run main.go, and as you can see here, it has successfully assigned the variable to value 27, and we've been able to print out that value below. Now, if we wanted to do something like add to the myAge variable, we could do myAge++, and that will increment the value of 27 by 1. Test that out. It's now 28. Or we could do plus equals, say 10, if I was to grow 10 years older, 37. And we can do minus equal as well, or minus to decrement the value by 1. And minus equals 10. Cool. Now again, we could follow the same approach as we did with the welcome variable, and we could be a little bit more verbose in how we are defining this variable. So I could do my age and then int. We could assign this to the value 27. And that would be the same as using the short variable declaration we have down below. As you can see, no meaningful change in the execution of our application. It's just that we've been a little bit more verbose in specifying the int type for my age. In the last video, we looked at how we could define some different types of variables. So we looked at how we could define the string type variable and the integer type variable. In this video, we're going to be looking at a concept known as constants. So constants are a little different from variables. They are effectively in-memory locations that cannot be changed throughout the course of our application's execution. Now, this is really useful to us as programmers. Say, for example, you were doing a mathematical application and you wanted to store the value of pi, for example. then using a constant here makes sense, as the value of pi is never going to change no matter what happens within your application. Now, when it comes to defining constants, we cannot use the shorthand variable declaration syntax that we covered in the last video. Instead, we have to use the more verbose option like this. And the quick way to convert welcome to a constant is to change var to const, like so. Now, from a practical standpoint, this does not change the execution of our application. It will still print out hello world. However, we now have that guarantee that the welcome string will never be changed throughout the course of this application execution. Now, so far we've only covered two distinct types. We've looked at the integer and the string. However, if we were to store something like the value of pi, so let's update this constant to pi, we could change the type of this to float 32 and then use 3.14, which is the value of pi. If we were to run this, go run main.go, you'll see that this has been stored as a float 32 variable and it has printed out this value here. Now, one other cool thing you should know about constants before you go is that we can leave them as untyped. So I could remove this type definition from the instantiation of our constant here, and we would still be able to run our application. However, the compiler would infer the type from this value. Now, leaving this untyped is beneficial if we have applications that use different sizes of floats. So for example, if I had a size variable that was using the float64 type, then under the covers, the Go compiler will automatically make the conversion from this untyped constant to type float64, and we're not going to see any compiler mismatch errors that we would see otherwise. So pi times size. Let's go and try and run this. So go run main.go. As you can see, everything's good. However, if we were to leave this as typed, you should see that, yep, mismatch types float64 and float32. So leaving this untyped in this example is going to be beneficial for us.